Hi, welcome to Conquer the Concept. In this video, we'll be doing the first 5 questions of the 2019 AMC. All questions were made by the Mathematical Association of America. Let's do the first problem. So, Ike and Mike go into a sandwich shop with a total of $30 to spend. Sandwiches cost $4.50 each, and soft drinks cost $1 each. Ike and Mike plan to buy as many sandwiches as they can and use the remaining money to buy soft drinks. Counting both soft drinks and sandwiches, how many items will they buy? Let's first translate this problem so we can better understand it. So Ike and Mike are two people that have $30 to spend, and they can spend it on sandwiches or soft drinks. They want to buy as many sandwiches as they can, and then use the remaining money to buy soft drinks. So sandwiches are $4.50 each. We have to ask ourselves how many times can 450 go into $4.5 go into 30 without exceeding it. So 450 times 5. Let's see. Let's do it in our head and see if that would make logical sense. So 450 times 5. So 4 times 5 is 20. And then 0.5 times 5 is 2.5. So 20 plus 2.5 is 22.5. So that's too low. Let's try 450 times 6. We can multiply it too. So 450 times 6. 6 times 0 is 0, and 6 times 5 is 30. So we can put down the 0 and then carry up the 3. 6 times 4 is 24, and then we add that to 3. That's 27. So with if we bought 6 sandwiches, we would spend $27. And if we bought 7 sandwiches, we would spend $4.50 plus 27, which is over $30. So 6 is the right amount. So after we purchase the 6 sandwiches, we would have $3 remaining to spend on the soft drinks, and the soft drinks cost $1 each. So they can buy 3 soft drinks because each of them cost $1 and we have $3. So if we add up 6 plus 3 with 6 sandwiches and 3 soft drinks, we would get 9, or D. So D is our correct answer. Let's go to problem number 2. 3 identical rectangles are put together to form a big rectangle, as shown in the figure below. Given that the length of the shorter sides of each of the smaller rectangles is 5 feet, what is the area in square feet of the larger rectangle? So 5 is here, meaning that this side is 10, because 5 plus 5 is 10. And then since rectangles have opposite congruent sides, this side would also have a 10 have a length of 10. So that means that the length of the bigger side of the smaller rectangles is 10. So this is 10 here, and this is 5 here. This is 10 here, and this is 5 here. This would make the rectangle 15 by 10. So the area of a rectangle is equal to length times width, and that's equal to 15 times 10, and this is equal to 150. So E is the correct answer. Let's go to problem number 3. Which of the following is the correct order of the fractions 15 11ths, 17 13ths, and 19 15ths from least to greatest? So we can make a similar problem that will make solving this problem easier. So the pattern with all these fractions is that the numerator is 4 more than the denominator, even like just the values are changing. So if we can set up a similar problem. So 4 over 2, the difference between the numerator and denominator is 2, and then let's try 6 over 4. Both differences between numerator and denominator are 2, and we can see which one is greater. So 4 over 2 is equal to 2, and 6 over 4 is equal to 1.5. So the smaller one is the correct answer. So fractions that have the smaller values and the same difference between the numerator and denominator will be greater. So this question is asking us from least to greatest. So we know that 15 over 11 is the 1, then 17 over 13 is 2, and then 19 over 15 is 3. So 19 over 15 should go first, and then the mouse should be opening to the right side. So we can use the process of elimination. So this one shows that 15 over 11 is the least, and that's not true. So we can X that out. And then this one shows 15 over 11 again as the least, and that's not right. And then this one shows 17 over 13 in the as the least, and 19 over 15 in the middle, so that's not right. And then this one shows 19 over 15 and 15 over 11 in the middle, so that's not right. And then this one is our correct answer. That means, let's go to the fourth problem. Quadrilateral ABCD is a rhombus with a perimeter of 52 meters. The length of the diagonal AC is 24. So AC is equal to 24. What is the area in square meters of the rhombus? So the area of a rhombus is equal to diagonal 1 times diagonal 2 divided by 2. So basically, we have to find the length of the other diagonal. So in a rhombus, all the sides are congruent. So, and if the perimeter is 52 and there's 4 sides, we can divide 52 by 4 and we would get 13. So 13 here, 13 here, 13 here, 13 here. So let's draw out like a nicer picture of that. So here, 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 here. This is 24. This is 13, and this is 13. So basically, what we're trying to find out is this value. We can break this up actually to a smaller problem, and this is all at right angle. So when you split the diagonal into 2, we would get 12 here and 12 here. So we can form a right angle triangle, which would look like this. If we zoom in on on this side, then we would get 13 here, 12 here, and we're trying to find for x. So we can use the Pythagorean theorem, or we can just, if you know the Pythagorean triples, you recognize that x is equal to 5. So that means that the total length of the second diagonal is 10. So we can substitute our values in this d1 times d2 divided by 2 to get 24 times 10 over 2. So 240 divided by 2, which is equal to 120. So D. So a tortoise challenges a hare to a race. The hare eagerly agrees and quickly runs ahead, leaving the slow-moving tortoise behind, confident that he will win. The hare stops to take a nap. Meanwhile, the tortoise walks at a slow, steady pace for the entire race. The hare awakes and rushes to the finish line, only to find the tortoise already there. Which of the following graphs matches the description of the race, showing the distance traveled by the two animals over time to finish? So we can use the process of elimination on this one. So A, we can put aside for later. B, we can put aside for later. C, we can also put aside for later. D, however, shows no steady pace. It shows fluctuations in the lines. There's no confident, there's no one slope for the one line. So we can cross out D, and the same thing with E. There's no one slope with E. So basically, we can use the problem to help us to find the answer between A, B, and C. So the problem says that the hare runs ahead, then it takes a nap. So for a time period, the time that the speed of the distance basically, and the time and the distance is stagnant for the hare. So this one shows A shows that A shows the correct path for the hare because it shows that stagnant time period. So does B, but C, however, shows a decrease in the distance of the hare, which doesn't which the problem doesn't show about, so we can cross that C. So between the differences between A and B is that in one, the one with the full undulating slope goes more up, and then the tortoise basically finishes last, and then the B shows that the tortoise basically finishes, and then the hare does. So the correct answer is B, and this is because the problem shows that the tortoise travels a greater amount of the same distance in the least less amount of time than the hare, and this one in B aligns with that. Okay, thank you for watching. And if you like this video and learned from it, please like and subscribe. Thank you.